Look at this marvelous question and give it a try. So pause the video and try it. Up till that I will be solving it. So here we should understand by looking at question that we need to remove x common firstly from this under root sign, because if you try taking this as t square then 2, you won't get satisfactory results. So the actual method for doing this question is removing x common, so getting half on its power will give us root x, and here 1 minus x. After this you have to play very smartly. You know that in the denominator you need all terms very similar to each other, right? Means you need root x and root x everywhere. So I will be trying to convert this 1 minus x into root x, and you know how to do it. You will simply write this as a minus b into a plus b equal to a square minus b square, right? So here it will be under root 1 minus root x into under root 1 plus root x. That will give me same 1 minus x as it is. And now again you have to think very hard and then divide and multiply this by 1 plus root x. The actual thing behind doing this is this root and square cancel each other and you get here square, because 1 plus root x and 1 plus root x multiply. And now you got to know why I did it so, because if I substitute this 1 minus root x upon 1 plus root x as suppose u, then I will get du as something upon 1 plus root x whole square, and that is here, right? So that is why we did so. Now let me find du. So du will be minus 1 by 2 root x into 1 plus root x. Again subtracting it from derivative of this will be 1 by 2 root x. So I will keep it common outside and just write plus 1 minus root x. So this one will be minus 2 upon 2 root x. So I got minus 1 by root x divided by 1 plus root x whole square. Now multiply both sides by negative sign and you have minus du equated with this, and it is this whole term. So we have du upon root of u, minus du upon root of u, and this is simply equated to minus 2 root u, that is minus 2 into what is value of u? U is 1 minus root x upon 1 plus root x, and this is our answer. Now you can also get this answer by another method, and that is by substituting x as sine square theta. So you have dx as 2 sine theta cos theta d theta. Now let us write all in terms of sine and cos, or whatever we get after putting in there. So this is 2 sine cos upon 1 plus root x. Root x is sine theta, and this is multiplied by, we have removed x common and got root x, and root x is sine theta itself, and we have in the root 1 minus x. So 1 minus sine square theta is cos square theta, and this one give me cos theta. Of course it is mod cos theta as per JE, but we don't focus on mod in indefinite integration. Okay, so in indefinite integration we don't focus on value of mod. Okay, and thus cos sin will get cancelled, and I have 2 upon 1 plus sin theta d theta. And you know, this is very famous form. You just divide and multiply by 1 minus sin theta, and this one will be 1 minus sin theta upon cos square theta, that is sec square minus sec tan, and 2 times what is integration of sec square? It is tan, and this is sec. So 2 times. Now value of tan is sin by cos, so sin minus 1 by cos, and this one will give us, what is value of sin? Sin is root x minus 1 upon, what is value of cos? Okay, you need to find it. X equal to 1 minus cos square, so 1 minus x, so cos is under root 1 minus x, and this is 1 minus x. Now again you need to play smartly. You need to write this 1 minus x as under root 1 minus root x into under root 1 plus root x, and then divide and multiply by under root 1 minus root x. So under root 1 minus root x, and this will be squared. Square and root cancel each other, and of course a negative sign is left outside, right? So this is minus 2 times of this, and you can clearly see that both answers match with each other. And thus we have 2 methods for solving it with a single substitution. If you try any other method, mostly you would be substituting it more than 2 times, or at least 2 times. These are only one time substitution method that I have provided you. I hope it would have helped you. Thank you.